So this is 1.2.1 underpinning energy concepts. So the first one asks you to look at all the different types of equipment and like substances and work out what their energy store would be. Okay, so bananas' energy store is chemical. Any food stores their energy as chemical. Two magnets attracting to each other would be magnetic. Electrical charged objects would be electrostatic, and then a marble rolling along a flat floor would be kinetic. Okay, what is the equation for efficiency? That's useful energy divided by the total input energy times by 100, because again, efficiency is a percentage. Okay, I kind of changed this one for what I would have expected you to do. Is a lit match would store it as chemical and would convert it to heat. Okay, stretch spring would store it as gravity and then would become kinetic. Postman lift in a box would be a store of GPE or something like that, and it would convert it to kinetic. And an egg rolling down a hill would be elastic at the top when you're holding it, and then it will be kinetic as it drops. Next question then. Calculate the value looked at each square. Okay, so we know that the input is 200. I counted all the squares, which was 20, so each square would be 10. Calculate how much energy is transferred usually by the block. So each square is 10. I counted there were 5, so that would be 50. And then I've drawn it quite small. Okay, you could have used more, but I just really went for the basics here. So 4/5 of wasted energy is transferred to thermal energy, and 1/5 is carried away by sound. Use the grid to show this for a clock. Okay, and I looked at that, and it's 4/5 is used as thermal energy, so I did it as though it was 5. 4/5 of 5 would be 4, so 4, and then the 1 going away as sound. Next question then is looking at calculating power. So power, and I've written the equation by here. Okay, power is current times by voltage. Okay, so you've got a volt, you've got a current, times them together to work out the power. Then it involved a little bit of rearranging the equation. So power, which is measured in watts, divided by the voltage would give you that as a current. And then the same kind of thing here, power divided by voltage would give you that as a current. Okay, that is all you had to do for these ones as well. Okay, so power times by voltage times by current to give you power, and then that gives you the power. Which one had the highest power rating was the room heater. Highest power rating is this. Unit for power is watts. Okay, so power is measured in watts, current is measured in amps, and then voltage or potential difference is measured in volts. Okay, moving on then, converting. This was some quite hard questions, but you could be asked to do this. Okay, so they might potentially give you an answer in kilojoules. You need it in joules. Okay, so you divide by 100. Give you an answer in kilowatts. You might need it in watts. You multiply by 1,000. Okay, I've also worked these two out for you. So to kilowatts to joules is times by 1,000. Watts to kilowatts is divide by 1,000. Okay, these questions then we're looking at working out units used and then timesing it by the cost. Okay, so the power was 0.3 because you have to make sure power is measured in kilowatts. The time is always measured in an hour, which was nice for this one. So all you did was work out the units used, which would be 0.3 times by the cost, which was 15, and I gave you 4.5p. Okay, exactly the same thing then for this one. Again, it was in kilowatts and hours, so you had 2.5 units used times by 15p. Gave you 37.5p. Last one then, be careful because that was in minutes, so you've got to change it to hours, which would mean 0.5 hours. So that would be 1.2 times by 15 would give you 18. Carbon footprint then is how much CO2 your actions release, so how much CO2 driving, walking around releases. Ways then we can reduce our carbon footprint include use public transport instead of driving, or walk instead of driving, shopping local, thinking about how much energy we use, changing things off on standby, things like that. Why are greenhouse gases essential to life? Because unfortunately we as humans release the biggest greenhouse gas in terms of CO2, and when we combust something, so when we burn fuels and stuff, they also release CO2. So at the moment, the way that we actually act as humans requires a lot of CO2. Give 3 examples of greenhouse gases: CO2, SO2 and methane. Final question then, very similar to power equals voltage times by current. This one then is working out resistance. Okay, potential difference though, be careful of that, means voltage. Okay, so you've got current times resistance. Looking at the symbols, so that's measured in ohms, amps and then volts. Okay, so that's easy. That first one just times them together. I've changed that because I just want you to work in amps and resistance and volts. Okay, so again, this is a nice easy one. 150 times by 100 would give you 1500 volts. Okay, the next one then we kind of have to rearrange the equation to get current. So potential difference divided by resistance, that would be 6 divided by 40, 0.5. Again, I don't want the answer in MA, I just want it in amps. So this one is volts divided by the ohms, the resistance, and gives you 0.3.